So this is 2018 BC number 2 with a calculator. This is a fantastic problem. The first part wants you to find a derivative, and you have a calculator available to you. You just need to make sure that you properly write on your test, I am taking the derivative of p at 25, and then the number that your calculator gives you. And you should be getting the number negative 1.179. But then it goes on and wants you to, sorry, I lost my place. Interpret the meaning of p prime of 25 using correct units in the context of the problem. What I would advise you do is take a moment to look at the units they are telling you. The input variable is given in meters, and then the function that you are taking the derivative of is given in millions of cells per cubic meter. So when you describe the units of p prime of 25, you need to make sure to say millions of cells per cubic meter per meter. And actually, why don't I just show you the answers instead of sitting here writing this, because that'll take longer. But that's not it. That's the bell schedule. There we go. So just to point out, it is millions of cells per cubic meter per meter. And you can write that with division signs instead of the per, and that's perfectly fine. Also, if you look at what they have written down, you can also say that the density of plankton cells is increasing at a rate of positive 1.179 million cells per blah, 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 blah. So that is part A. Then part B. Part B, it starts getting good. Consider a vertical column of water in the sea with a horizontal cross-section, with horizontal cross-sections of constant area, 3 square meters. Now, read those words carefully. They're telling you that the area is 3 square meters. So if we have a vertical column of water that is a particular depth under the surface. Now, they didn't describe what the shape looked like. You could think of it as a circle, a square, whatever, but it is some, actually, this probably looks better if I draw it as a rectangle because I can put perspective in the drawing of that. So that's now submerged under the surface of water, parallel to the surface of the water. But volume is found by taking a teensy tiny change in height, and that will be our dH, our differential of the integral we need to set up to find what we are looking for. We are looking for how many plankton cells there are when we are given the density per cubic meter. We need to multiply the density by the volume to get quantity, but the volume is the area multiplied by the tiny dH. And the area was flat out given as 3. So 3 times dH is the volume, multiply that by the density, and then add all of those together from a height from from a height of where did I just go? From 0 to 30 meters. I'm getting all sorts of distractions today. Sorry. Okay. Then let your calculator do that. And by the way, I really, really recommend that you do not write this function on the paper. Just use the name P of H. And then let your calculator finish the rest of it. Do pay attention to the wording where it says to the nearest million. In the initial directions of free response, they tell you to round your answers 3 digits after the decimal point unless told otherwise. This is one of the unless told otherwise moments. So then I'm going to grab the answer. You should be getting this number from your calculator, and 1675 million plankton cells. And also you can see the scoring guideline. Now, moving on to part C. I'm going to erase the other work so that it doesn't get in the way of reading part C. This time they're telling you there is some function u that is greater than or equal to f of h for all h greater than 30. And they are telling you the integral from 30 to infinity of u of h. Now, they're telling you also that the column of water from part B is k meters deep, where k is greater than 30. You need to write an expression involving one or more integrals for the number of plankton cells in millions in the entire column. Now, and then I'll come back to the after this period. I'm going to put a star right there. So I already have this written to get us started a little bit. Make sure you are aware that this is a property of definite integrals. This fact right here. Now, through our understanding of improper integrals, we should realize that this, actually, that is the answer to the limit as k approaches infinity of this definite integral from 30 to k. And we know that we are only adding on to that integral as k gets larger and larger and heads to infinity. So naturally, the answer to this limit is definitely greater, maybe equal to, but definitely greater or equal to this. Now, this is density, though. This is just looking at density, and what you're actually looking at is the quantity, which is going to be taking the density and multiplying it by the volume of 3 times dH. Now, if I'm going to multiply that integral by 3, then I need to multiply this integral by 3, which means that when they tell us that that u integral is 105, then this is equal to 3 times 105. But make sure you're clear that this needs to be added to what we found in part B. And if you go back and read through the problem, it says that the P function is the density between 0 and 30. But the u function, where did that go? I'm trying to find where it says it. The u function is dealing with h greater than 30, greater than or equal to 30. So you're going to need to add what you got to part B onto the 3 times 105. Then, going back to this star, explain why the number of plankton cells in the column is less than or equal to 2,000 million. So at that point, I'm just going to grab the answers, which are, there we go, to just show you that you need to be writing, and people are going to present it in slightly different ways, but essentially you need to have this inequality that shows that your density from 30 to K is less than or equal to 315, but add that to the quantity that you had gotten in part B. And then you have to specifically state it's less than or equal to 2,000 million. Now, I want to say additionally that if you accidentally have the wrong answer in part B, if it keeps this final answer under 2,000 million, then you can get full points with the incorrect result from part B. But unfortunately, if that number puts you over the 2,000 million, then you can't get all the points in this because you're not able to show that that is true. So that is part C. And then part D just takes a turn of its own. If I can get this to move over, that would be fantastic. There we go. For this problem, it gives you just a whole new batch of functions, and it has to do with the boat moving on the surface of the sea and just wants to know the distance traveled. You're going to throw that in a formula. All you need to do, since it's a calculator section, is write down the formula. And you do not need to write the function, the actual expressions of the function, but the name of the functions alone. So you can just say x prime of t, y prime of t. Don't write the whole thing in. But just tell them this is the formula I'm using. And then write the answer, and that is your total distance traveled. And that is the whole problem there.